Start, sir.
Hello, welcome to the first live session of Structures 1 course. This is Professor Anup Ghosh, and in our team, two teaching assistants are also available. They are Mr. Shupen Kumar Shah and Mr. Vikash Kaushik. They are senior research scholars under my guidance at the Department of Aerospace Engineering. So, if you have any question, I think we can start with. There are a few questions already we have seen, and those questions are difference between multispar and multi-ring construction of wing. Which construction of wing is better? If we talk about this, so if we talk about that multispar wing case, in general, all wings are made of more than one spar. Minimum 2 spar are generally used. In very old aircraft wing, there used to be configurations where a single spar used to be used, but now it is much more popular to use multi-spar and get it distributed. So if we see difference between multiple spar and multi-ring construction, which construction of wing is better, and so it is desirable always to put more than one spar, at least 2, and to continue in that concept. And multi-rib, definitely it has to have multi-rib, otherwise we cannot maintain the profile of the section. So we need to go to the multi-rib construction. So good morning everyone, whoever has joined in the live session. So the next question, if we look at I see in the live session, like in Uddin and Shantanu Chakraborty and Mr. John, Mr. Rohan, sorry, Rahman. There are many. Mengani, S. Mengani is also there. So good morning everyone. So let me address the second question. If I go to the second question is, can your course should be easily understandable? So it is difficult to say. I have tried my best to make it easy, but I'm not sure how far I have done it. So course recordings are all done. It is up to you whether you understand the course well or not. If you have any doubt, we may discuss, we may continue. So the third question, if I go, what is aircraft designed and how to design the aircraft? This topic, I think I can discuss a little bit more. I'll try to discuss this later. The third question. The fourth question, if I go, which is the best material to fabricate regular class RC aircraft? Wingspan 3 meter. This is, though it is not, okay, we can bring in here, which is the best material. Best is always changing with time, but with the consideration of present day material, if we do with 3 meter wingspan, in our department we have built 3 meter wingspan glider, solar glider, that we made with wood only, balsa wood, but instead of that, that experienced flutter. Flutter is a dynamic phenomena that we have not discussed in our course here, but we can go for advanced materials like laminated composite material. Now laminated composite materials are available in our country also. There are some companies in Bangalore and there are some companies in Gujarat also. They have come up with fabrication technology. You can go for fabrication with that. You can buy sheet from there and you can easily use some diamond cutter to cut those in shapes, and you can use those things for fabrication of 3 meter wingspan UAV or RC aircraft. It is not very difficult to fabricate it. That will give you better stiffness, better stability. Frequency will be higher, so it will be easier. Being particularly flutter can be avoided with that, I guess, though it requires a lot of other testing before we come into those. And in live session, I don't see much questions. Only few of them have come here. So let me discuss the question as I told you to discuss last, that is the aircraft design and how to design the aircraft. Aircraft designing is altogether a huge, vast area to discuss with. Aircraft design cannot be discussed over the desk here, but since there are not many questions, now we can start discussing aircraft designing. Aircraft designing is basically put into two, three segments in the sense we say the conceptual design. Okay, aircraft design is always there to talk with, but there is one more question. What is the difference between statically determinate and indeterminate in both external as well as internal? Okay, statically determinate and indeterminate question. While we talk about, while we are not able to find the solution with the equation of statics, or in case of plane thrust, that there are 3 equations, and in case of space stress or structure, there are 6 equations, and we are not able to, unknown is more than that, we call that as statically indeterminate structure. But while you will be going to the more advanced courses, you will see all the structures are comes into the category of statically indeterminate structures, and advanced numerical methods are used to find out solution for those. If we over a video conference like this, it is difficult to tell you what is statically determinate and what is not statically determinate. I think I have covered in my course in a simplified way. Is equation same for both? Force equations and moment equations are there. Principally, those equations are same. Yes, what you are saying m plus r equals to 2j, that is for plain truss case we usually do. So for other structures it is not like that, and it is, as I told you, depending on the plane or space structure, truss or structure, whatever. We consider truss as the simplified structure to continue, and that is the reason we always bring example of truss, because number of unknowns are defined that way. Sir, what is the basic function of formers? And I cannot understand the difference between the formers and bulkheads, right? This is really a confusing term. It's a good question. Formers are, we can consider as a combination of, the other way I should say, a bulkhead is combination of formers, you can say. A bulkhead, if it is divided in small parts and distributed over a length, we can say that as a former. So that is the most modern way of constructing aircraft. So that is, if you look at the formers technology to build the modern aircrafts, where you will see there we won't find that big bulkheads. So we can consider that those bulkheads are distributed as formers throughout the section. Next question, if I go for Mr. John, pin joint 2D statically determinate condition. Question 5, correct answer is given as 3m plus r is equals to 3. 3j, which is correct, sir. This will discuss later. This one is well defined in book. I don't find any point of discussing this thing. So if there is a mistake in the question, we'll correct it or we'll take care of it. What's your thought of urban air mobility? Urban air mobility is a new term now, and this is getting day by day more popular. So it is difficult to predict now, but it is getting popular with advancement of engine related to electric engines. It is getting popular day by day, and the design of aircraft is also becoming much easier day by day. There are different softwares, as I was talking about in relation to the aircraft design. Aircraft design consists of 3 basic stages. We say the conceptual design, preliminary design, or the detailed design. So conceptual design stage, what do? We try to fix the configuration, the range, the payload, whatever it is going to experience, and we try to fix the overall parameters. How many engines are required, how it could be. We always try to discuss designing with respect to fixed wing configuration, but as with respect to the urban sometimes it is difficult to imagine 3D object on a 2D paper. Can you please suggest some tricks or idea? Imagination tricks and idea, how it is own matter. I have tried my best to show you different figures, different isometric views to give you the 3-dimensional understanding, but otherwise it is difficult to give you. That is the reason there we lack lack the facility of interaction or classroom interaction. Unless we have classroom interaction, it is difficult to give you 3D imagination. Even if here, if I use my hands, I cannot give you 3D because it is a 2D thing what you see. So it is difficult. So the next question, as in case of a landing gear problem, it is difficult to imagine. Yes, it is difficult to imagine. I understand. That is the reason I have tried to give you different types of isometric views. Probably you have seen while I have solved the problem in the wing bending also, there I have tried my best with additional figures to give you understanding how the bending moment acts on the wing. How do we calculate segment by segment the bending moment and we add it up in the table. So unless we go in classroom, in a visual conventional mode classroom, it is difficult to give you 3D understanding. Then, sir, why IC engines are not used in commercial aircraft in order to decrease weight? This is though in my not in my area, it is a totally propulsion subject area. But see, always in whenever we think of the aircraft or a flying vehicle, their weight matters, efficiency matters, and the thrust produced in unit time is also matters. So I see in internal combustion engines are used in piston prop aircrafts. In old days, it used to be used. Still, it is used. There are still many agricultural aircrafts which use IC engines, but not the IC engine which is used in car. So there is a big difference. There are more thrusts are required. So in a different configuration, the engines are fabricated and the rotary motion, more thrust is produced, and that way it is used. So it is used, not that it is not used, in order to decrease weight. Decreasing weight is, though as I said, it is a completely a different area. Okay, in Rayleigh method, we assume the curve of the deflection, and our answer will be based on the assumption of the function. So what should be the criteria to assume the function for the curve of deflection? Right, this is a very, very good question. Rayleigh method is very, very important method to understand. We need to consider the functions or the shape which is practically possible and which is conforming to the boundary condition. It has to satisfy the boundary condition. If you look at the example what we have solved, there we considered the sine function, because while the deflection takes place, the deflection is very close to the sine function. So that is the reason we got a relatively close answer to sine function. But if we consider more variables, and then the results will be more close to it, and we need to consider more terms in the series to find out the better solution. So the basic fundamental idea is that you have to consider the solution admissible for the boundary condition. If you consider a shape which is not at all possible while the deflection is taking place, then you won't get a result. So that is a prime criterion in case of Rayleigh method. So with that Rayleigh method discussion, we go back to the aircraft design topic as we are considering. So in that, the first conceptual stage, we try to fix the dimensions, type of engines used, what type of wing, tail plane, those are to be used, what should be the length, diameter of fuselage, all those things we do, try to estimate roughly the gross weight, because gross weight governs the total design. And then part by part we go for the preliminary design. Preliminary design gives in preliminary design we go for the aerodynamic design in a refined way, whether we are able to lift the total weight or not, what should be the cruise speed, cruise velocity, all those things we continue. And in case of detailed design, we go for articulated manner, the structures or propulsion parts to design piece by piece, everything like in that detailed design stage, we go for designing the individual spar, stringers, ribs, schemes, all those things part by part we design. As there are several methods available for solving the problems, there are only for our convenience. These are only for our convenience or any other perspective. Okay. This is another good question. Many methods are discussed. So why those many methods? What I understand from the question, why those many methods are discussed? What is the aim of discussing that many methods? So it is to give you the idea how the methods are invented from one to the other. And in some cases, we don't want to go for a detailed analysis to find out the reflection. And we may go for a simplified analysis like the unit load method or Castigliano's theorem method to find out deflection. But why we go for advanced derivations for applicable maybe for finite element analysis or some other cases, there we may go for relative method or advanced method for formulation. So keeping in mind all those things, different methods are developed and are used. But all the methods are used still in industry depending on the case. If we want a easy approximate solution, generally we use those Castigliano's theorem method or other methods. And while we go for fundamental research, we generally go for those things related to advanced energy methods like Rayleigh or other methods, variational principle approaches, those we use and we find out. Okay, as there are several methods, okay, then like the results will be quite similar with all the several methods, so there are many advantages of method over the other method. So that's what I discussed, that it gives advantage depending on the situation, what we want to do. So we do that depending upon the situation, what type of solution we want for easy estimation, approximate estimation, we go for Castigliano's theorem or unit load method and others. And for detailed things like the finite element method, that is based on other variational principle or relative method on those principle, and then other advanced way it is done. So with this respect, if we come back to our discussion related to the aircraft design, as I was discussing, things what we are learning in this course, like the deflection, and in the next part what we will be learning related to the stress. So stress determination, strain determination, and how and what is important in which case. Those things, if we see, those are applicable mainly in time of detail analysis. So that is the reason in many cases we see that the aircraft design is to some extent disjoint from these basics things what we learn in our second year, third year level or fourth year level. The first stage of conceptual design is done, and then for preliminary and detailed design we go for using the knowledge of detail analysis what we learned during our BTech course, maybe in second year, third year, or fourth year level. So detailed design becomes more important. Otherwise, nothing will sustain. Say if during design, if a simple reef fails or the total aerodynamic lift loss will take place and it will lead to failure. So final important thing is the how do we design each and individual part, and that is the reason we go for designing. We do give more stress and fundamental things in our BTech courses and in this type of courses. Will text transcript files to be provided for your course? Yes, text transcript files are being prepared. I will get the text transcript files. But I have a question to you. Why are you interested for text transcript files? How does it help? Anyway, so in the next part of the course, what we will be covering is fundamental theory of elasticity. And theory of elasticity is the most fundamental way of analyzing structure. So with respect to that, unless you have clear idea of stress strain in two-dimensional and three-dimensional level, we won't be able to solve problem. And in our aircraft structure, torsion is also a very important problem. So from theory of elasticity point of view, torsion problems are also solved in our course. We have also solved problems associated with a hole in a structure. That is very important because to make aircraft structure lightweight, we always create hole, we remove material, try to reduce the weight. Whenever there are need of material, we remove the material and we try to reduce the weight, but that may have adverse effect. You will see that there are examples, and how the hole shape should be, that is also important. There are examples of rectangular window which led to a catastrophic failure of aircraft. Total fuselage got torn apart. That created bad problem. So after that, people were behind understanding the problem, and they have found out that from the corner of the, sometimes you give additional comments. Okay, text transcripts for additional comments. Okay, if that way it is beneficial, it can be, but see, while we speak, we sometimes leave coherence of language. So that you have to see. Okay, if it is beneficial, we'll try. We are in the job, we'll try to solve that problem. And as I was discussing that from the corners of the rectangular window of aircraft, there was a catastrophic failure. And then people understood that because of that corner, stress concentration takes place. And that stress concentration leads to failure. So following that, we we thought of putting elliptical or circular holes, and that is to some extent stable till date. So, but how that happens, we should have clear idea about those things. That is the reason we are going through the course in the second half portion of our course in the detail of theory of elasticity. Sir, I have one more question. If I want to work on any research project with you, what will be the procedure? I think that is not the course topic. Sir, I have one more question with you. What will be the procedure? So this is not a course topic today. I would not like to answer that now. Maybe sometime later in this window. So, so theory of elasticity, understanding theory of elasticity is important that way. As somebody already have raised a question of three-dimensional and two-dimensional imagination, there also you will see how do we imagine three-dimensional stress condition, strain condition. But again, I have tried to put figures, I have tried to explain with visuals, give you the idea of how stresses act and which way it acts, how does it behaves, but it is difficult to say all those things over this type of interaction platform. Can tell about jet engine. Sorry, jet engine is not my topic. I cannot tell you more. But I can tell you that jet engine, the way you know, I don't know your background. Technically, jet engines are getting outdated nowadays. Most popular configuration of engine is turbofan engine. So you need to go more into those engine segment. Engine is interesting, I know, but this is structures related discussion, and I'm not the person to say anything about those engine area. Okay, so as I was discussing about the theory of elasticity approach, theory of elasticity, we need to learn to visualize stress and strain configuration. How does it act, where it becomes maximum. Then comes the concept of principal stress. Principal stress means what is the maximum stress is experienced, normal stress is experienced. How do we find out those and how those things are important. A good example, though I have not discussed in the course, but you can easily find out the solution that problem I can say now. Maybe if possible, I will discuss sometime in our next interaction session, if I remember. I am a young scientist at national level. Okay, his question will come, I guess. So it is something like, if we take a chalk, the problem I was discussing, if we take a chalk and twist it, we'll see that the chalk fails in a 45-degree angle. Why that failure happens, that is very interesting thing. But if we take other materials like tensile testing of steel bar, if we go for, if you are from engineering and solid mechanics background, I guess all of you are from that background, you will find that the failure is not on the surface in that helical manner. It is inside in some 45-degree angle, but not on the surface. So that cup cone shape is something different, and here it fails in a helical manner. So those things, why that takes place, why, how, which one becomes important, which failure strength becomes important, those things are, though failure we have not discussed, but that we cannot visualize unless we have a better understanding on the different types of stresses and strains. So with this note, if I don't have any more questions, I'm feeling, sir, what is your opinion on that? There is only one AN225 aircraft. What would be the reason of only one? It is not only one aircraft is there in cargo segment. There are many cargo aircrafts up there. But AN225 is really huge aircraft. It is made huge for particular purpose, but for that it has different disadvantages also. Like the wingspan is more than 80 meters, so it is not operable in many airport in throughout the world. So there are a few airports where it can be used. So there are disadvantages along with that huge size also. So that is one major disadvantage of AN225. Advantage is that the huge capacity, that we agree, but you try to search internet now, all these data are available over internet. You got to spend much more time. You can find many aircraft, but you will find that most of the cargo aircrafts fall in that wingspan category of 80 meters, and that was a major bottleneck for A380. They reduced it with lot of effort. The A380 design was, initial design of was more than 80-meter wingspan, and they reduced it to, I think, 79.8 or something, close margin. Okay, anyway, that's a different topic. Sir, can you tell about the Tejas aircraft? No, I was involved in Tejas aircraft with some testing only, but I don't have much more idea about it. We did some structural testing, that's all, but I don't know more about Tejas aircraft. So at that cargo aircraft group, if you see, different cargo aircrafts are built for different reasons. I know one firefighting aircraft which is a modification of Boeing 737, I think. That is civil aircraft is totally completely changed to a firefighting cargo aircraft. There are huge tanks are installed inside, and those tanks are specially made to store firefighting retardant agent, and that is used. So it depends on the purpose. Design is a huge, completely a different area. As I told you, in our fourth year class, design is covered, and they are only covered the conceptual side of the design. Sir, can Tejas carry nuclear bombs? No idea. Sorry. So, as I told you, depends on the use. It is the other way, AN225 or antenna of 225 is also hired by US agencies like NASA also to carry their rocket parts from one place to the other. So it is useful. So everything has some good side and it has some bad side also. So the overall way our course is designed to give you some idea about what kind of what kind of things are, what kind of loads are experienced by aircraft, where which type of load comes, how do we analyze, try to find out bending moment shear force of the total aircraft, and how do we find out each and individual part deflection. Those things we have covered in the pre-mid-sem portion. And in the post-mid-sem portion, which is more fundamental in nature, there we have covered about theory of elasticity. If we learn theory of elasticity, that will open more avenues in the structure side, structures analysis side. Sir, I am a 8th class, in 8th class, and I love to know about aircraft. So can you tell which book should I read? Okay. The good book is in that stage is Flight Without Formula. I think that is written by Anderson. So there are 4 parts, Flight Without Formula. You can easily buy those. Low priced editions are available. Those are very good book to start with. Flight Without Formula. That will really create good enthusiasm and inquisitive idea about aircraft. Apart from your courses on NPTEL, I will be happy if you share some guidance to work on any research topic in IIT Kharagpur. This is not a topic of discussion. Apart from your course on NPTEL, okay, same question repeated. So please give stress on theory of elasticity part, stress strain behavior part, that is more fundamental in nature. That will come in the post. I'm saying post mid-sem. It is not post mid-sem. We'll start from 5th lecture. So 5th week lecture, 5th, 6th, and 7th, 5th, 6th, 7th, and 8th week lecture. You will get those. I have tried to define stress strain first, and then we have solved some problems. And with that, we have concluded our course. So we are almost at the end of the session. Because of some technical problem, we started a few minutes late. But anyway, if there is no more question, we may try to conclude. Mr. John is saying, sir, final exam question pattern, time, duration, etc. Can you please tell about it? It is already well defined by organizers. There is no scope of going more than that. So you follow those, you will get the answers for this type of questions and other things. So there is a suggestion for G. Kumar from Uddin, Mr. N. Uddin. You may follow. So if you don't have any more questions, we would like to conclude today's session. And with this, thank you everyone for attending the Aircraft Structures 1 course. If it is possible, please go for the exam. I want to mean that certificate exam, and it will be nice experience for you. And with that note, we will conclude today's session and join back again with the maybe in the 7th or 8th week. I'll join in one more live session and would like to interact with you. Thank you. So
Sir, please wait, sir.